We have started from the outset to build what we consider the best hard rock lithium plant and staff and operation and company in the world. We started this journey sort of 5 years ago with a pre-feasibility study and a definitive feasibility study. Then we did the front-end engineering design. A lot of that focus was on operability and maintainability, and that's been the number one design focus, obviously, for Kathleen Valley. Outside of the obvious process flow sheet, which we did an enormous amount of test work to sort of define. Our observation from some of the more recent projects, both lithium and other projects in the state, is that it's important that the plant runs. So you've got to put the effort in the design phase so that when you start it up, you can run it, you can maintain it, and you can actually get that recovery, especially for lithium. It's all about recovery. We want the plant to run long enough that the operators can actually get the recovery that the design says it should be delivering. So this conveyor has deliberately been broken into two parts. It's unusual, it costs a lot more money, but it means that we maintain a small section of belt in the highest wear part of the plant, and then we don't just decimate 300 to 400 metres of belt. All our conveyors are standard width, so we only stock one belt. Keeps our spares costs down. Our gearboxes are common. Our rollers are common. We put a lot of focus in the plant on commonality, so we don't need a massive, massive warehouse with 10 lots of spares, because we have one roller, one belt, one gearbox suits 5 or 6 conveyors. It's just smart thinking. That sort of thinking takes time, and you have to build it into the design, and that's the sort of work we've done. So this has been built with an oversized apron feeder at a very high angle to allow us to actually squash, if you like, the ROM pad down and keep that height low, which means we put less rock up there, so it's cheaper to build. It means the trucks for the next 20 odd years travel up to a lower height. So you could even say there's an ESG angle associated with it because they're going to burn less diesel. But it keeps everything low, and if you keep things low, it costs less to build in terms of concrete and height, but it's also more economical. We've designed hatches everywhere in the plant. You'll see these in all of our chutes. Yeah. These hatches are massive. You see the liners that we're putting in there, they're massive. This thing has been designed so you can get in, you can fix it, you can lock it back up, and you can get it going quickly. The focus on the screening building was reducing the height of the building. So we took 2 floors out of this building from the initial design, and the reason we focus so much on height in this building is height equals energy, energy equals wear. So we've focused very heavily on essentially squashing this building down, making the chute work as small as possible, making the falls for the rock as small as possible. If the fall is small, the energy it carries and the damage it does when it actually impacts things is a lot less. We worked with Lycopodium, obviously, from the PFS scoping study all the way through design and obviously into construction. Lycopodium is a tier 1 engineering firm with a lot of hard rock mining experience, and that's what we are mining. It's a hard rock. We're aware of it, it's abrasive. We've designed our plant with Lyco and others to ensure that we have a lot of rock on rock contact, so we're wearing rock against rock. We've designed our chute work so it's big. This is not a first time miners plant that we built out there. This is built on many years of experience. Lyco have real lithium experience from down south at Greenbushes as well, and we brought that to bear in terms of how we've designed the float circuit and other parts of the wet plant. Lyco have a lot of experience in terms of milling, and we brought that to bear in terms of how that milling circuit's designed. And this chute, I think, is a perfect, I would call it a quintessential classic example of what we've done everywhere in the dry plant. The chute, as you see, steps down like a ladder. In this chute, when it operates, that whole quadrant there, that whole portion of the chute will fill full of rock. So when the rock cascades down here, it is literally sliding on rock all the way through the chute and onto the conveyor. What does that mean? It means we're not wearing out liners in terms of the actual chute itself. So you can actually see the ledges in the chute and where they'll fill up with rock and the actual wear blocks we put on the corners of those ledges. Internally to our own company, we've got experience over many, many years operating and maintaining the plants, and it's that maintenance aspect that has driven a lot of the design. It's that operability that's driven a lot of why the floors and the walkways and the I guess the general access around everything is so big. It's big because we want access. It's big so we can get cranes in. It's big so we can get
people in. It's got platforms so that we can pull things apart.
We know we're going to be relining the crusher very regularly, so it's got dedicated overhead craneage, and that's a feature you'll see through our entire processing plant. Everywhere where access is a little bit restricted or we think we're going to need regular maintenance, such as crushers, such as screens, they've got dedicated overhead cranes in. Now, a lot of people put overhead cranes in. We've put them in everywhere throughout the plant. Everywhere where access is tight, it has an overhead rail. And it means that you can then not have to tie up 2 cranes and a whole bunch of people to lift things in and out. You've got a built-in crane in the plant.
All sounds very basic, but you don't know that you need a platform there till you go to fix it, and then the plant gets shut down. We've put in standby duty pumps across the plant. We've focused heavily on wear materials, so urethane lined pipes, rubber hoses on all the bends. Lots and lots of ceramics have gone into the plant. This is a key learning from other operations. Every area where we think is going to be high wear, we put ceramics. We've put a lot of focus on wear because we know things are going to wear out and we accept they're going to wear out and we're planning for them to wear out, but we're planning also to be able to fix them.
It's all about uptime. Uptime's all about feeding constant material to the SAG mill. The key thing with this bin that's fairly unique in lithium is it's not a big open stockpile. It keeps the dust down, which is important for our native title holders, but also means we keep a constant size rock feeding into the SAG mill. Constant size rocks equals constant grind equals constant float recovery. It's all about feeding that mill the same size product at a constant rate, and we put a lot of effort into this bin to ensure that that's what it does.
One of the reasons that we split the build of the plant between the dry plant and the wet plant was to ensure that we could put a big focus on the dry plant early. We definitely wanted to decouple, I guess, the crushing, screening and generation of the mill feed product from the rest of the plant. We didn't want to be commissioning the entire plant in one hit. So our intent is to commission the dry plant well ahead of the wet plant, and that's well and truly on track now to happen. Monadelphous were chosen for the wet plant for multiple reasons. Obviously, they were cost competitive. They're definitely a Tier 1 premier contract in the state. They have the people, which is very important in WA at the moment. You have to have the people to do the work. Secondly, they have the equipment. Not many people realise that just having the people doesn't guarantee that you can do the work. You actually need the cranes and you need all that other infrastructure. And if you look around our site now, there are at least a dozen cranes on the job. It is a real reflection of the equipment and the craneage that Monos have brought to bear on our project, which is what's driving the progress that we're seeing every week.
We deliberately split the plant build into 2 portions, Dive and Way Electrical doing the front end or the dry plant. They're smaller, more nimble contractors and they're able to get in fast and get finished first, which is what we wanted, and Monadelphous doing the back end.
And the build with Monadelphous in the wet plant has been set up so that we can progressively commission the wet plant in parallel with running the dry plant, in parallel with construction of the wet plant. There's a lot of thought gone into this schedule so that we can stay on track for first ore. The approach from the outset has been very considered, very measured, very consistent and very focused on doing what we say we're going to do.
Going to the SAG mill now, I think of it as the business part of what we're doing. Clearly a big part of the operation. SAG mill spinning equals money. Normally the first thing you look at when you go on a mine site is the mill running. If the mill's running, then the process is working. When I first started in the mining industry, the first real mine I went to had the control room next to the mill. It means that the operators and the supervisors and the people running the plant are right next to the bit that matters.
Because the key part of the project is every 3 to 4 months, that mill will shut down and we'll reline it. And the reline is what drives our entire, I guess, uptime of the plant. So we've put a massive effort on the mill floor alone and the mill deck and the craneage and everything around the mill about making sure that reline happens efficiently.
When the liners wear out, we bring a reline crew in to reline the mill. That happens every, say, 4 months. And relines are all about time. So the less time you takes to rotate the mill, the less time it takes to get the liners up onto the liner floor, the less time it takes the liners to come out of the mill. A typical reline, it's 6 to 8 minutes per piece in and out for the mill. So we focus very heavily on having enough space here, and you can see the space is vast. Pre-shutdown, we'll load this up with brand new liners. We've got a park bay for our liner handler, so we'll test the liner handler and make sure it works before we put it in place. But the liners are insanely big. That's so it doesn't wear out in 5 minutes. It's got a large square box before it feeds into the feed chute. That fills full of rock and it's rock on rock again. So that philosophy is carried all the way through the plant.
Every piece that comes in and out of the SAG mill when we reline it is 8 minutes. So we put a massive effort into limiting the number of pieces, to limiting the number of turns of the mill, to having enough space up there that you can have 50, 80 people up there working. You can have a couple of 100 tonnes of liners sitting up there on the floor. You can drive a forklift in. We've bought the best liner handler money can buy. We've bought rock breakers. We've bought platforms. All of it is set up about making sure that that reline is efficient.
Mill deck is about space. We'll run a forklift up here. We've got a dedicated hoist to bring liners up. So again, focused on relines. We've got dedicated compressor air for this region only. So we have enough air for when they reline the mill. We've got a lot of space for liners, a lot of space for a liner handler, a lot of space for a forklift to run around on the deck and keep that time down. We don't want to be down much more than 70, 80 hours every 3 or 4 months because that downtime directly impacts how much concentrate we actually make. This platform has been designed specifically so we can get 3 bulk rows on the SAG shell every rotation. Less rotations of the mill in a reline sequence means less time to do the reline, and it means a faster shutdown. What we've built here is pretty much unlimited access to be able to maintain these 2 valves. Fitters and mechanics can get to them. An overhead crane can come in and drop the new valve in and pull the old valve out. The Y-piece that'll sit right here can be lifted out and a new one lifted in. The main feed line is fully accessible from both sides. This is just simple stuff, but it's what we think differentiates us from a plant that's just been built. This has been built to be maintained.
One thing we did observe from others is that it's best to have a singular flow sheet. If you have 2 flow sheets that are intertwined and one part of the flow sheet has an issue, it actually massively impacts the second part of the flow sheet. By having a singular flow sheet like we have, we focus on crushing the rock, making a 35 mil product, feeding it to a mill, making a 180 micron product that then gets fed to a float circuit. We don't have interwoven dense media separation impacting on the float recovery, which a lot of other operations do. Ours is purely focused on achieving a particle size and a feed to that float circuit, so we get a constant feed at a constant particle size, which means then we can focus on recovering the lithium.
This is probably one of the key features of the design of the wet plant. We've actually got a very linear or a spine system, if you like, for the plant. So we've actually got a walkway that runs the entire length of the plant that allows you to step off into every area of the plant, be it magnetic separation, be it flotation, be it thickening, be it filtration, and it joins with the mill deck. So the operators can come straight from the mill control room, they can walk through the platforms here, straight down the centre of the plant. It's all about access, it's all about operators looking at what they're operating, and it's all about being able to get at what they're operating. And it's been designed that way.
Water quality, I think, is something that isn't widely spoken about in terms of the lithium game, but certainly from a flotation point of view, we have a separable flotation water circuit, and we've got reverse osmosis to generate even cleaner water as part of that flotation circuit. So our focus on recovery, our focus on operability has also been complemented, I think, by the amount of effort we've put in ensuring that the water quality that we feed into our float circuit is the best it can be. And when I say the best, it's as close as possible to what we tested to as part of the extensive 3+ year test work program that we put together. In terms of the equipment, we've bought everything that suits what the process flow sheet defines. We've actually bought equipment that we think is the best in class, and we've up-spec'd that equipment, again, based on learnings from other operations. Our thickeners have a whole bunch of extras added to them that we know didn't work at other lithium operations, and we've tried to counter that. Our float cells are best in class. The mill, probably the best on the market. The crushing equipment, tried, tested, proven equipment for this type of rock and this type of material and this type of application. I mean, even something as simple as valving, we've put a lot of effort into valves. We've bought the best on the market in terms of valves because a valve can shut the plant down as easily as a power cut. So we'll have a stocked warehouse full of parts, a maintenance team empowered with procedures, with processes ready to run, operate, maintain the plant at startup. It is a construction/business readiness deliverable as part of what we're doing. It's definitely not what a typical junior miner would do, but certainly within the company, we've all done this a few times, so we know it's important to start this way. Otherwise, you're always chasing your tail. I think in terms of the market, we've been very transparent in that a large percentage of our plant was designed for 4 million tonne per annum throughput. There is a clear plan to expand the operation to 4 million in the future. So there are chunks of the plant, like the crushing circuit, like flotation, like filtration, like the thickening parts of the circuit, that are designed for 4 million tonnes per annum. So even though we're starting at 3 million tonnes per annum, we've got this latent, if you like, built-in capacity. And if you can fix things quickly and efficiently, especially if you can fix them on the run without shutting the plant down, it's uptime. Uptime equals more con, equals more recovery, is more money for the company ultimately, right?